John was born ready.
All right, very good. We'll just switch the order up then. Next presenter is John Donahue with Missouri DOT. John is a fellow Illini, but he fled Illinois many years ago and never came back, so he's happy there in Missouri, I guess. His presentation is the 10-year anniversary of the Route D Unbonded Concrete Overlay, oldest U.S. project with Geotextile Interlayer. And I'll comment that we built the 6x6 design on Geotextile just a few years ago in Illinois, sort of based on the success in Missouri. So I'm interested to hear John's presentation.
Okay, Chuck. Is there a clicker to advance, or do I just use this laptop? Okay, that's fine. All righty. This will be a pretty simple, straightforward presentation. In fact, I did it specifically just for this because Tom was looking for topics, and I thought, what could I do? And I thought, hey, Route D, hey, it's 10 years. Oh, okay, yes, that makes sense. Let's do a 10-year anniversary update on it. I just had a few of our technicians go out a couple weeks ago and do survey on it, so this is hot off the press type information. But anyway, I'll just give you a little background information of why this project was significant. Just to let you know what we had going on here. This was what we call a letter route, but letter routes are typically pretty low volume. This was actually a concrete pavement that was constructed south of Kansas City, and it was kind of a bedroom community type portal, I guess, but there was some truck traffic, so it wasn't it wasn't insignificant in terms of the type of loadings that it experienced. It had been constructed in 1986, so it was a little over 20 years at the time we rehabbed it, and we had 30-inch joint spacing with only 1-inch dowels, and it was a little over 3 miles long between the two routes that it connected. At the time, and right now the ADT is up to about 10,000, so it's increased a little bit, but when we did the rehab it was around 9,300, 5% trucks. Truck traffic's picked up a little bit too, so but the thing about it was really, really badly decracked. Our problem overall statewide, we have relatively good quality limestone, except in the northwest part of the state. And in particular in the Kansas City area, we have some really susceptible rock to decracking. And so this was designed, I think, really prior to us adopting a smaller max size gradation to kind of mitigate the decracking. So, and I'll give you an idea of what this looked like. Okay, I want these pictures to kind of soak in with you a little bit. I mean, some of these you'd have to take a running start to get from one slab to the other. We showed these. I remember we had a joint presentation years ago with Kansas, and the people from Kansas were like, "We can't believe you guys even had this road open to traffic." But so when we toyed with the idea of doing a concrete or specifically big block overlay, I was a little skeptical. I thought that we were really challenging it with the condition of the pavement. There's another one. So, and you may or may not be familiar with this, but we are big on doing alternate pavement designs. And in this case here, we actually let the contractor select either a 5-inch concrete overlay or basically a 5 3/4-inch asphalt overlay, which would have been the typical treatment for this. I have to say, though, it was somewhat hardwired. I mean, we had a pretty large local contractor in Kansas City that was kind of eager to do this. So we knew with the setup we had that it was probably going to go concrete. So we were pretty optimistic that was going to be the case. And then on the shoulders, we'd also given the option of going with either concrete or asphalt. And we wanted to make it. This is quite the first one of our. We had done, and Manic showed, mentioned a slide from our experience with the 4x4 bonded concrete overlays. This was technically one of our first, or really our first significant, what we call big block unbonded overlay. And so we're going to incorporate steel or fibers, but the real significant aspect of this is we were going to try using a geotextile for the interlayer instead of the conventional asphalt interlayer that we've been doing up to that point. Now, just to rehash, and a lot of you know this already, but we'll go over it. I mean, the purpose of the interlayer, and this is an idea that was adopted from Germany, and actually, in a way, you could say this project was not only the first in the country, but maybe the first in the world, because the way the Germans used it, they used it as a separator layer on cement-treated bases. So it wasn't, they weren't even applying this between two concrete pavements. I guess that's a fine point to argue, but anyway, so the advantages of using this type of geotextile, which was not your Sam's Club weed control fabric. I mean, there's a little more to it. Was obviously providing the separation that an interlayer should between for an unbonded overlay. Also to actually provide drainage. I was kind of skeptical of this, although I think from some of the data that Minnesota did, it actually bore out that you really do get some transmissivity of moisture, and you can pull it away from the pavement out towards the shoulder. So there are some specifications for that. And also, too, because of the thickness of it, probably to some degree anyway, mitigating or dissipating the, some of the horizontal, I guess, or possibly even vertical strains from coming up through the overlay. This was the specifications, and I know that we were working with the Transtech group, of course, who, George Chan, who you've heard already, he works for them, but specifically Sabrina Garber, who some of you also know, she speaks and can write German, so she actually translated the German specifications into English, so this was her version of it. And you can see just looking at that there is an emphasis, on the things you would expect with the fabric, such as tensile strength and elongation, but also you have those spec conditions for the water permeability under different pressures and a few other things as well. So, and also too the weight, I guess I'll mention that. At the time, the recommendation was, obviously in terms of metric, weight per area, but we converted it to ounces. So in terms of ounces, it was somewhere between 13 and 16 ounces per yard. I think this particular fabric that we had was somewhere in the 15 range. And I haven't really followed this closely the last 3 years, but I thought the recommended weights have kind of inched up closer to maybe 20 ounces. I don't know if that's true or not. I thought I'd heard that they're a little bit heftier, but that's what we had at the time. Now, you could see based on the prior condition that we probably needed to do a little bit of prep work to the existing pavement. We weren't picky. We actually allowed the contractor to use virtually any material. Even if they wanted to use an unbound material, we would have allowed it just so they could essentially have a flush surface to place the fabric on. In this case, the contractor elected to use a grout slurry, which I would suspect was fairly low strength. So while it's better than an unbound material, it's not like it's not exactly a permanent fix. So the gist of this is that we didn't really improve the existing pavement a whole lot. We were just trying to get a flat surface. And there were just some shots from the construction itself. And this was new to this contractor, obviously, because we hadn't done this before. So I think the standard roll sizes were either about 14 or 15 feet. I don't know if they've shortened those roll lengths, but so we basically had some overlap on the center line, and then on the outside shoulder, we pulled that fabric out maybe a couple feet. So that's really where it ended. And then they put an asphalt shoulder on there. So we didn't really try draining it all the way out to the edge of the shoulder, which probably would have been a better idea, but we just weren't, going to invest the money in that much additional fabric. And some of the conditions to try to look forward, obviously, is avoiding wrinkles, cleaning the surface prior to placement, overlapping it, try to overlap it by not more than 8 inches, and then avoid conditions where you actually have three pieces overlapping, so you don't build it up too much. Securing the fabric at the time, the only recommendation was to basically use driving it with nails and around a 2-inch size galvanized washer. Since then, I know more recently, although we haven't done it, and I'm glad to hear. I mean, at the time, I thought it'd sure be nice if there was some type of adhesive to use, and that has become the standard practice now. But it was coming up with an adhesive that wasn't going to saturate the fabric and obviously reduce some of its properties. So I guess we have reached that point. So that's an evolution that's for the better with the fabric. And then of course, it is a black surface, so you want to try to reduce the mix temperature to the degree possible, or try to make it uniform and cooling down the surface a little bit. So saturated. This is just showing the slip-form paver, pulling it through. Just normal bull float finishing, texturing, curing, and that's just a core showing it did bond. I mean, it would come off of the old concrete if you pulled on it, but it did bond pretty well to the new overlay, which makes sense. And this was the end result after they saw it into 6x6 panels. And this is a fairly recent picture. I don't know if this is this year or the year before, but okay, now starting here, here's some current pictures of what it looks like. And this is, in the interest of full disclosure, I'm showing you the warts, but it's not as bad as it looked. My experience on any type of concrete overlay, especially the thinner ones, and there's probably a variety of reasons for why this happens, but most of your problem areas are going to be in the transition zones. And usually once you get a couple 100 feet or so beyond that point, things really get better and they stay consistently good again until you get to the other end. And that's the case here as well. This is the north end of it. And there was a bit of patching that was going on here. So about the first 600 feet, you do see, it doesn't look like a great success. There was some corner cracking, there were some shattered panels, mid-panel cracks, but most of it, once you get beyond that point, this is what you're seeing. In the interim, there's a couple other spots where I think primarily because we had drainage issues, and like here you can see this is in a cut section, so it's not too surprising we probably had some water trapped in there, and there's a patch there. And you can see the discoloration on the shoulder. You can see evidence of pumping going on there. In those cases, there's a couple other patches that we had. Now here we don't have patches, but if I was going to guess a future location for a patch, it might be in an area like this, where obviously we do have some. But you're going to remember what I said, the fact that we pulled the fabric out a couple feet into the shoulder, but we did not allow. Go ahead.
How thick was the tuber shoulder?
It was the same thickness as it was 5. Oh yeah, I don't know if I even mentioned this. It was basically a 5-inch concrete overlay. The asphalt shoulder was the same thickness too. So roughly 5 inches across. We might have, I think, for estimating purposes in the bid proposal, probably applied a fudge factor of maybe a 1/2 inch average of concrete to account for surface irregularities. I suspect we did. So, but I mean, the design thickness was 5 inches. And but mostly, this is what you see going down the line. I mean, it's just 3 miles of pavement, a little over 3 miles, and yeah, it's good. And like I said, there is truck traffic. I mean, some significant truck traffic. I don't know if that's a grain truck or whatever, but you can tell there's a lot of axles on it. So there are some, I don't know, Brett, do we have I thought there was a quarry somewhere nearby too down in that area, but might be using that road as well. Okay, so, and this is the south end of it. In a little bit, not the south end was not as bad really as the north end. In fact, there really wasn't a lot going on here. There was a few cracks, panels. It transitioned actually to full-size panels where we went to full depth pavement to tie into the intersection. But overall, the results of this survey, we looked at over 9,800 panels. Well, I didn't do it. Somebody else did it. And out of all those, 192 were cracked or spalled. So that works out to a failure rate of just under 2%. Now, I did have to make a call looking through the distress sheets. I was tailing this. There were some spots with minor spalling. And, they're relatively small spalls, maybe a couple inches across, not affecting rider performance or anything like that. It's more just of an aesthetic deficiency. So, maybe that'll lead to something larger in the future. It could, but I kind of felt for the time being, that wasn't worth adding. If I had included those, it probably would have added another 1% to this. So, if you really want to be conservative, you could possibly say that there is about a 3% failure rate, or let's say distress rate, because I wouldn't call all those panels failed. So, out of 3% after 10 years, I would, I consider that a success. And again, half of those failures were located within the first 600 feet. So that's, for, does that work out to, 16,000 feet or whatever it is, 600 feet, half of what's going on is right there at the beginning of it. Average IRI is around 88. For a road like this, that's, just services local traffic basically. Like 10,000 ADT. That's not insignificant, but it's not a major traffic either. I think the posted speeds are around 55, maybe 60 on there. So it rides well. I've been on it several times lately. I guess the findings, again, overall, performance, can't complain. And considering the initial condition, I honestly didn't expect it to be this good after 10 years. So, remember what it looked like, prior to placing this overlay. Just reiterating, usually the transition areas are, prone to higher failure rates. Drainage definitely played a role in some of the crack slabs and failures that we saw, and really can't say there's any distress that was linked directly to the interlayer. I can definitely link distresses in unbonded overlays to the asphalt interlayer that completely disappeared at some point in time, decided to leave the pavement system. But so far, our experience with geotextiles has been pretty positive. So anyway, that's my very basic, simple update on Route D. Any questions, Tim?
Do you know what the initial IRI was of this project?
No, I don't. I can only imagine.
No, I mean after it was paved.
Oh, right after it was paved. Trying to remember. I think it was probably. I think it was in high 60s, 70s, somewhere in that area.
So really, compared to nowadays, not really that smooth. What you're rated to gauge so far has been pretty flat.
Right. Exactly. Yeah.
You're right.
What we rate as a good pavement, and our criteria for acceptable pavements is basically dumbed down to whether or not it's below or above 100. So technically, this would be considered a good pavement by Missouri standards.
You might mention to him, John, because of the issues with the asphalt stripping out and causing creek, we pulled and switched over.
Yeah.
We allow the industry to switch automatically to geotextile to avoid that issue.
Yeah, it's cheaper. I can't see why if we give you a choice, why would you not use the geotextile? But it's getting to the point to where I would just about mandate the geotextile because of the problems we've had with the asphalt interlayers. So,
All right.
thank you.
Try this one more time.